This is the last part of our investigation for Unit 6, Activity 1. We're going to look at the tangent, and we're going to try to make a connection to the tangent ratio. So again, let's start by trying to make angle ABC 30 degrees. There we go. Now, we want to determine the ratio of the opposite over the adjacent, which we know is the tangent ratio. The opposite is side AC, which, as we saw in the previous part of this investigation, is the y-coordinate of point A. The adjacent is side BC, which, as we saw in the previous part in this investigation, is the x-coordinate of point A. So I can do that calculation on a piece of paper, or I can use GSP again. To do that calculation, I want the opposite, the y-coordinate, divided by the adjacent, the x-coordinate, and there we have it. We have an answer of 0.58 approximately. Now, the next part of the investigation asks us to try to find another location where we can move point A and get the exact same ratio, 0.58. Notice though, unlike in the previous investigations, we've used both coordinates to determine the tangent ratio, the x and the y coordinate. For the sine ratio, a reminder, we use the y coordinate to determine the sine ratio. For the cosine ratio, we use the x coordinate. But for tangent, we're actually using both. The opposite over the adjacent is the y coordinate over the x coordinate. So now where can I move point A so that I end up with the exact same ratio, 0.58, for my tangent ratio? Now if I try to move it into the second quadrant, let's see what happens. I want 0.58. As soon as I move into the second quadrant, you can see there's a problem. We have a negative ratio, and the reason this is because our x-coordinate is negative. We are taking our y-coordinate dividing by our x-coordinate. Well, our y-coordinate is positive, but our x-coordinate is negative, so there's no way that our ratio can become positive. Let's try it the other way. Let's go into the fourth quadrant. Same problem. This time, our y-coordinate is negative, and it's being divided by the x-coordinate, which is positive. So the tangent ratio isn't going to be 0.58 here either. What happens if we move it into the third quadrant? We know that the x and y coordinates are both negative here, but that actually helps us here. Because since we're dividing the x and y, the y coordinate by the x coordinate, and they're both negative, we're actually ending up with a positive quotient. Now I need to make sure that this ratio is 0.58. So let's see where that happens. We're getting closer. There we have it, 0.58. The opposite over the adjacent, the y coordinate over the x, is 0.58. Notice that the x and y coordinate are both negative. The y coordinate divided by the negative x coordinate gives me a positive ratio. Now, what is the angle in standard position and what is my related acute angle? Again, it's easier to answer the second question. The related acute angle is the angle between the x-axis and the terminal arm, so that's 30 degrees again, angle ABC. Now this time, what's the angle in standard position? The angle in standard position is the angle from the positive x-axis all the way around to that terminal arm. Well, we know from the positive x to the negative x is 180 degrees, and we're adding on 30 degrees. So 180 plus 30 gives us 210 degrees. So what that means is that the tan of 30 degrees, which was 0.58 as we saw, is equivalent to tan of 210 degrees, which as we can see right here is 0.58.